So 39. Y equals x plus 2 over x. And it says find the equation, this one you meant, right? Find the equation of the tangent line to the curve at a given point. So they are telling us 2 comma 3. You don't have to do this, but I always like to say, okay, let me see. If I plug in 2 here, 2 plus 1 is 3, yes, that's correct. Good. I found very few errors, not in this book, in a different one, but that's why I like to check. Fine. So I'd like to talk about the function 1 over x first. So forget about this for a moment. We are focusing on just 1 over x, because this is another very important rule that I want you to add to the list of rules. I also wanted to show you something. Let me see where I wanted to show, oh, don't tell me I'm logged out again. Please don't tell me I'm logged out again. I want to be here. I just wanted to go to, I did not put this, and if you want me to, I will. There is I have it in Calc 2. It's a list that is at the end of the book. If you want me, I can put it in. So it's a list of all formulas. It has about 10 pages, and I have it in Calc 2. And let me see where I have it. I have it here. I think in every module. This is chapter 7. We're not covering chapter 7 in this class, but it's this. The list, don't I have it here? Okay, so calculus reference, these are the pages at the end of the book with all the formulas. So if you want me, I can email it to you, or I can post it in our course. And you have everything that we are discussing in this class and way more. Okay? So there are 10 pages. So it starts with pre-calculus and some algebra and some graphs. And again, this is our special graph, the arctangent that we looked at. Okay, and then you have some other references, other graphs. You have trig, and you have the derivatives. So the differentiation rules, right? So what is the rate of change of a constant? Of course, is 0. So the sum, you have everything you want in here. See the derivative of e to the x, and so on and so forth. Okay? So if you want me to, I can post this so you can print it out. If not, you have it at the end of the book. Okay, so back to our problem. So I copied it, so let's continue. Now, this is something that we need to know, and we don't want to think about it. Like, for example, whenever we differentiate this, I want everyone to say this in a blink. Because if we get stuck on very simple situations, then we will advance much slower. So this should be carved in stone right now. And this will be carved in stone in a minute. Now, we want to differentiate this function, and we said we always should simplify the function as much as possible before we attempt to differentiate it, to find its rate of change. So is there another way of presenting 1 over x? I haven't heard from Brooke, from Harrison. I haven't heard from Chris, Gray, Ella, anyone. Please, it's okay. It's okay if you're. Oh, I just said because I don't recognize your voices yet. I'm sorry. Sorry, Chris. It wasn't intentional. I just wanted to get your attention, though. So, can anyone tell us how to rewrite 1 over x?
X to the negative x.
Exactly. Awesome. Good. And now this is so much easier to differentiate. What will you say?
Negative x to negative 2.
Yes. So negative x to negative 2. And now we want to go back to this form as negative 1 over x squared. So in a blink, when I say this, you have to say this. And when I say this, in a blink, you have to say this. Okay? And this is your proof. So we should never ever discuss this again. Of course, if you have a question, I will always answer it. But I hope that moving forward, this is embedded in your brain. Okay, so now I can go back. So y equals x plus 2 over x, and now this will be so much easier to find the derivative. How do I get this? What is the answer here? So a constant prime is 0, and x prime, what is the slope of x? That's all it means. What is the slope of x? Exactly. So x prime will be 1. Good. So now let's differentiate this, keeping in mind that 1 over x prime, remember 2 over x. 2 over x is the same with 2 times 1 over x. You should always see this when you need it, and you should always see this when you need it. Okay? Either one. When I need it like this, I will use that. When I need it like this, I use that. So then what would you say? When I differentiate 2 over x, what would the answer be? Anyone?
Is it negative 2 over x squared?
Very good. That's it. That's it. So please remember these two, they're super important. Okay. I think, oh, I didn't finish. Okay, so we determined the derivative. We were asked to find, I just forgot what I was doing. So we are asked to find the equation of the tangent line at y equals x plus 2 over x at the point 2, 3. And we determined y prime. In order to find the equation of the tangent line, like for any equation, can anyone give us the point slope form? I will write it here.
The formula is y minus y1 equals m times x minus x.
Brilliant, thank you so much. I do have the point. But how do I determine the slope? Any idea?
To determine the slope, you plug in the original x value into the derivative.
Exactly. So the slope, see, I don't like this notation because I have to write this. I would have preferred this notation now. They mean the same thing. This one says evaluate the derivative when x is 2. This one says evaluate the derivative when x is 2. But there is no parentheses, so I can plug it in. So I have to write it with a vertical bar and then right here x equals 2. So in this situation, this is more convenient than this, but they mean the same thing. So 2 over 2 squared, which is 4, 1/2, 1 minus 1/2. So what is the slope? Very good. So this is the slope for that particular situation, right? So if, I'm not graphing the function, but if the function is this, and this is the point 2, 3, this line has to have slope 1/2 or f prime of 2. This line is the tangent. Its slope is 1/2, which is f prime of 2 at this point, at this x. All I have to do is just rewrite y minus 3 equals 1/2 x minus 2. I have to distribute. So I have 1/2 x, 1/2 times negative 2 is negative 1. And I have to bring 3. It was negative. I'm adding it. So then the equation of the tangent line is 1/2 x plus 2. The slope of the tangent line is 1/2. The equation of the tangent line is 1/2 x plus 2 at the point 2, 3 for the given function. Okay, so I'd like to illustrate one more thing and then we should continue. I would like to look at 59. Find the points on the curve, blah, 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 where the tangent is horizontal. So let me copy the function. So this is in 59. Y equals x to the third plus 3x squared minus 9x plus 10. Horizontal tangent. This, I'm not graphing the function. At this point, the tangent is horizontal. Horizontal tangent. What is the slope of any horizontal line?
0.
Yes. So how do I find the points on this graph of this function where the tangent is horizontal? What do I need to determine first?
That'd be the value of x.
Careful.
The derivative?
Yes. So I need to find y prime. Can anyone find y prime in a blink for us? Boom, boom, boom.
3x squared plus 6x minus 9.
3x squared plus 6x minus 9. Brilliant. What do I have to do now with the derivative? In order to find those points on the graph where the tangent is horizontal. Remember the
0.
yes, because the derivative is the slope of the tangent. In this case, we are looking for points where the tangent is horizontal, which means the slope or the derivative is 0. Awesome. So remember, it's either a maximum or a minimum. Not necessarily, but we'll get to that to discuss it in more details. But it can happen in other situations. So y prime equals 0 because we are told that the slope is 0. If the slope were 4, of course not horizontal, but if the slope were 4, I would have said this equal to 4. So then I have 3x squared plus 6x minus 9 equals 0. Okay, we connect the concepts so we remember this. When I find the limit, I plug it in because I don't know what I'm facing. When I find the derivative of a function, I always take the time to simplify the function first. Do my legwork first before I differentiate. Now, because we've never talked about this before, I have to solve an equation. I always simplify it. Always. I have to identify what it is, identify it, and then simplify it. Always. I don't just go ahead and find the solutions. No. I simplify it. Is there a way of simplifying this equation? We simplify it. You are on the right track.
Because it's a polynomial, so you like...
Yes, but we are not factoring it. We are simplifying the equation. How will you simplify this equation?
Divide by 3?
Yes, we will divide both sides by 3. So we have x squared plus 2x minus 3 equals 0. This divided by 3, this divided by 3, this is divided by 3, 0 divided by 3. Only now I will factor. Or use other methods, quadratic formula, who knows. Can anyone give us the factored form for this?
It's x plus 3x minus 1.
Awesome. So then we have two solutions. And they are?
Positive 1 and negative 3.
Very good. Positive 1 and negative 3. We are asked to find the points. How do I find the points? Because they are asking us, find the points. Find the points where the tangent is horizontal. How do I find the y coordinate? Say it again.
Plug the x value in.
In which?
The original.
Absolutely, yes. Of course, of course, of course. Great job. Okay, so here's what I recommend for this. I'm going to share my screen. I'm going to go to y equals. No, I didn't mean that. I'm going to go to y equals, clear everything, put in this function, x to the third, and then plus 3x squared. And then minus 9x, and then plus 10, because I don't want to do this by hand. I see the function, yes, it's correct. I need to plug in 1. I need to plug in negative 3, and I get the answer, 5 and 37. Done. I don't recommend you do it step by step and plug it in here, because you may make errors. Put the function in and then plug in, boom, boom. Awesome. Moving on. Let me see how I'm with time here. 16 minutes. Okay, so I can say a few things here. So in 3.2, we're going to look at more differentiation rules. And they are product, like a function times another function prime, and quotient or ratio, quotient, so f divided by by g prime. Okay, these are completely separate rules. They, I would not say that they are self-explanatory at all. So we have to memorize them. I like to memorize them or present them in the following way. The book shows it slightly differently. Maybe somebody else will teach you something else. I'm fine. I recommend these two. First function divided by the second function prime is the first function prime times the second minus the first times the second function prime divided by the second function squared. So f over g prime is f prime times g minus f g prime divided by g squared. Your book twists this and twists this, but if you twist these two terms, that's incorrect. So be very careful. So this is the quotient rule. The product rule, that's why I like to present the quotient rule first. The product rule is the same thing with the top, but it has plus. So function 1 times function 2 prime is just this, but with plus. First function prime times the second plus the first times the second prime. So this is the product rule, this is the quotient rule. So that's why I said, with a limit, I know you're going to hear this 15 times today. With a limit, you know how to address. I'm not going to repeat that. With a function that we're asked to differentiate, you know what you need to do. We always simplify it first. The same thing with an equation. When we solve an equation, we always simplify. Do not divide by x. So if you have here x cubed, x squared, and negative 9x, you cannot divide by x. You can only divide by a number that is not 0, because x could be 0. So the same thing here. When we are given a function like this to differentiate, first identify what it is. When we are given a function like this to differentiate, first identify what it is, and then continue.